Welcome to RAM Academy. So in this video we are going to understand some basic concept about electromagnetic waves and material interaction. So what is written on this presentation? Light, microwave, X-ray, TV and phone transmission are all kind of electromagnetic waves. Electromagnetic waves are a group of energy waves that are mostly invisible and can travel through empty spaces, means the space or empty vacuum. This energy bombard our body all the day long, but we are only aware of very small portion of them, which is visible light, color, infrared lights and ultraviolet lights. So as you can see these images. So what are some waves? Radio waves, microwaves, infrared waves, visual waves and ultraviolet, X-rays and gamma rays. As you can see there, wavelength. So wavelength of radio is 1000, microwave is 10 raised to power minus 2. So I am taking here pen, 10 raised to minus 5, 0.5 into 10 raised to power minus 6 of X-rays and gamma rays 10 raised to power minus 12. As you can see, the frequency of particular of them 10 raised to power minus 6, 10 raised to power minus 2, 10 raised to power 12, so it's 8, 4, 10 raised to power 4, 10 raised to 8. So as we all know, frequency is inversely proportional to lambda. So as we know that V is equal to nu, where nu is frequency, lambda. So let's move on further. So electromagnetic energy is created by vibration that produce waves. Each electromagnetic waves emit a different level of energy. This energy travels silently at the speed of light and produces a signature wave with a unique range of length, energy and frequency that scientists can identify and measure. So we can measure the energy of electromagnetic waves by measuring its frequency. Frequency refers to numbers of waves of a vibration created during a particular period of time. As you can see, the tuning fork present in the water creating a particular frequency of 256 Hz. Since there are many tuning forks, so randomly I am picking it at 256 Hz. Signal networks producing a signal for producing a frequency signal for mobile. Numbers of waves greater than the energy of radiation. In general, the higher the frequency or number of waves, greater the energy of the radiation. So here we can see that energy of radiation is directly proportional to the numbers of waves So when we use the term light, we are referring to a group of electromagnetic waves called visible light. Each individual wavelength within a spectrum of visible light wavelength using a particular color. And when a light of that particular wavelength strikes on our eyes, we perceive that specific color sensation. So as you can see, when the white light goes to the prism, the white light split. So this is nothing but a splitting effect of a light. When it crosses through a prism, you can say Vibur. 7 colors which is formed through the white color. Another popular group of waves from the electromagnetic spectrum involves infrared waves. Infrared red is a type of electromagnetic radiation that involves heat, thermal radiation. All object emits gives out and absorb taking thermal radiation. So when we put in a thermal camera, you can see the object emitting and observing particular type of heat, and here you can see sun. So when light interacts with observed or absorbed, reflected or transmitted. So you have learned about something called coefficient of absorption, coefficient of reflection, and coefficient of transmission, that is equal to 1. So what is absorption? In very simple manner, the loss of light as it passes through a material. As you can see, when the light passes through this particular material, what is happening? Something is reflected, the return of light by the material. Some part of, you can say, it can passing through the material, that is nothing but transmission, and you are saying that some part of it reflected. So what is reflection? Reflection is generally a bending of light as they pass between the medium. As you can see, if we draw a normal to this particular point, since I have not taken a ruler, so when we are saying it is towards the normal, and then it is bending away from the normal. So this is angle of incidence. Let me change my pen to the red. As you can see, it is angle of incidence, and here you are seeing the angle of emergence. So what is written there? Light rays travel in a straight line towards the glass block, and rays change their direction outward as they leave the block. Change direction inward, they enter the more dense material. Look at an example of absorption. When you go to the dentist, one of the first things is to obtain an X-ray of your tooth. Unnecessary exposure of X-ray radiation can be harmful, so doctors try to minimize the area that choose electromagnetic waves interact with your body by making your special protective clothing. So as you can see, what is happening? So that limited amount of area, when you are, so unnecessary exposure of X-ray radiation can be harmful. Yes, it's very harmful. Doctor try to minimize by area that the electromagnetic wave interact with your body by making a special protective clothing. You can see here in this PPT a special protective clothing. Why do cloths? What these special cloths do means what is exactly what these cloths are doing. What are they fighting with these X-rays? So what these protective cloths contain some amount of tensile known as lead in them, a high density of element. In the high density of elements allow X-rays to be absorbed by the atom in a lead, decreasing the energy of the X-ray, and lead in turn shield your body from unnecessary radiation by absorbing X-rays. So here you can see the picture of lead representing by PV. So here you are seeing this diagram that only the upper body was imaged because X-ray hitting the lower torch were absorbed by the lead apron. So see, you are seeing this lead apron, it is absorbed only in the upper body of this particular body you are seeing due to this lead. Another example of absorption of electromagnetic waves in our daily lives involves the use of microwave. I know most of you can afford microwave, but there are some people who cannot afford the microwaves. Microwaves are widely used to quickly heat up the food. Microwaves are also referred to as range of waves in the electromagnetic spectrum with a specific wavelength and frequency. So, means what is the purpose of buying a microwave? So what do actually microwaves do? Microwaves utilize the fact that food contains water molecule. So food contains a water molecule. So a water molecule absorbs the microwave, giving the heat as the molecule vibrate. When a microwave is turned on, the energy from microwave is absorbed by the water molecules in the food, making them vibrate, and this vibration gives off heat, which warms up your food. Look at some example of reflection. As you can see, boy standing on the mirror, smiling with a beautiful face. I hope your days will be going like that only. And when you're seeing house, near a riverside, you are seeing the reflection of that particular house. If you have ever visited New York, if you got a chance, you can see this beautiful picture, of New York, I think so. This beautiful image of this particular building, towers, and this fancy merry wheel. So reflection occurs when the light is returned by an object. Although many objects reflect lights, common examples include mirrors and smooth water surfaces. How does an reflection lights or mirror? Reflection involves two rays. An incoming ray, that is known as incident, which I have taught you in this PPT, and ongoing reflected rays, that is nothing but an reflected rays. When an incoming rays, as you can see in this, when an incoming ray strikes a mirror, the rays changes direction, and this rays is now reflected off the mirror. The angle of incidence ray and the angles of reflection rays are equal in all reflected light of smooth object. So here what I have said, that when a light is striking down to the angle of incidence with an equal amount on a smooth surface, such that it is making an equal amount of angle of reflection. As you can see in this mirror, what is happening. Reflection can also involve scattering of light. See, here you are seeing the two pictures, smooth surface and rough surface. Here you can see the equal angles, but made by light. But here you are not seeing because of a rough surface. So when a light strikes an object that has a rough surface, and the light scatter everywhere instead of bouncing off at an equal angle. So here it's bouncing at an equal angle, but it is neither bouncing, it is scattering. See, you have seen the scattering of light in misty cloud. Let's look at an example of transmission. An opaque object will not pass a light. We know translucent object will pass some little of the light. Transparent object, it will pass out the light. Transmission of light is the passing of light to an object. An object have different levels of transmission. Opaque object reflects or absorb all light, so you won't be able to see behind opaque object. Translucent object allow only a part of light through and letting you slightly see behind all the object. Transparent object pass all light through it. So now, how are shadows formed? This is one of the most important thing. So, if you wanted about a video about diffraction, you can mail me at ramacademy@gmail.com. Shadow, or you can comment it below down. Shadows are formed when the light is blocked by an object. Shadows are produced when a light hits an opaque object, which prevent the light beams from passing through it. The light beams are absorbed by the object and cast in shadow. So the light beam is, you are seeing this in many of the cartoon videos. You are seeing this gentleman coming in a moonlight, and you are seeing all the rays of a moonlight that is absorbed by this particular man, and the beam is stopped by this an opaque object, as the human body is an opaque object, and you are seeing that this man is here because of the light passing through him. There is a formation of a shadow. And now let's take an example of reflection. Reflection involves bending of light as it passes through one form substance, and a common example of friction can be observed when you go fishing. Due to reflection, you perceive this in that aren't located in the proper location. So when we are seeing a fish in a pond or a particular lake, as you can see the buoying, what is happening, that the actual depth we cannot just by seeing we can admire that what can be the depth of this particular object. But here what you are seeing, that the fish appears to be at some particular or distance. This is nothing but a perceived location, means a false image is generating. It appears to be. So what does the refraction happen? Why does refraction happen? This is the one of the most important question from 9, 10, 11, 12 we are hearing. And if you will go to some BSc courses, physics if you take, so what does this refraction? The bending of light is due to change in speed when a light passes from a less dense substance than air to more dense substance, and it slows down and bends into more dense material. On the other hand, when the light passes from water to air, speed up and bend outward. So here what you are saying, that when a light here due to refraction, here you are seeing the bending of this pipe, and you are seeing how it's happened. So light interaction object can involve combination of absorption, reflection, transmission, and refraction. And common example that absorption means what is happening. What means what for what purpose this example I have brought means whatever the object you are seeing in this environment, what type of color you are seeing is because it is emitting that color, because all the rays are absorbed, only that color you are seeing, that is that waves are sending off it. So a common example that has both absorption and reflection in one class: if you are wearing a blue jeans, you see the color blue, and because the jeans absorb all the color but reflect blue. So electromagnetic waves can also change the temperature of an object. So earlier we saw example of microwaves can heat up the food. Other electromagnetic waves can be used to change the temperature of an object. As mentioned before, infrared is a type of electromagnetic radiation that involves heat. When the infrared waves come in contact with an object, the waves transfer heat to an object. So what you are seeing, the sun, you are seeing beautiful sun, the sun is transmitting heat, and inside the home it is you are saying that there is an increase in temperature. You can see this thermometer, at first it was very about 60, but after that you are saying that it has rose to 80 degrees Celsius. So horrible condition in future it may be. That's why people in modern houses use some techniques to overcome these all things. Material are chosen for specific application due to their special property. Material that conduct heat rapidly are thermal conductors. Material that limit transfer call are thermal insulator. Material that allow the flow of electric current that are electrical conductor. Material that limit the flow of electric current are electrical insulator. Is a very important. Conduction involves transferring heat substance between substances that are in direct contact with each other. Good thermal conductor include metal, aluminum, steel, and copper, and good insulator include non-metal, wood, styrol, and these are nothing but all the bad conduct ones. Good insulator. A popular example of conduction can be found in a cooking. So what is nothing but conduction is nothing but transfer of heat. When a pot is on a stove and your heat is transferred from stove to pot, the pot is made of metal, so it is good thermal conductor. Most pot have a handle made of rubber so that you don't feel heat when you are picking up the pot from the handle. This is because rubber is a good thermal insulator and doesn't allow heat to be transferred to the handle. So material can expand or contract due to presence of expansion of heat. So here we are saying that a thermometer is neither rise up, it is below up to 30. Now what is happening? Thermometer are a great example that involves substance expanding and contracting due to varying temperature. Thermometer contain a special liquid mercury, which is a good thermal conductor. The mercury molecule expand and get bigger as it get warmer and get smaller as it cools down. The result in the liquid moving up the arms and drop down. The liquid moving up the when it's warm and drop down. When it's cold, the molecule expand as it get warmer because the volume of the liquid increase as it's heated and slow decrease as it's cooled. So this is contraction. So what you are saying, this is our heat. Now it is going to expand. Here the temperature increases swiftly. Now when there is no provision of heat, so it is cooling down. Due to cooling down effect, it cools down. Material are also chosen for electrical properties. Most metal are good conductor of electrical current. Metal allow electrons to flow from one atom to another. Therefore metals are commonly used in today's devices such as computer, phones, and TV. Electrical insulators do not let electrons flow easily from one atom to another. Electrical insulators are used to protect us from dangerous effects of electricity flowing through conductor. Good electric insulators include non-metals such as rubber, air, and wool. So this is all summary. If you wanted to read out, thank you for watching.